Hello students, myself Ashish Chawla, and today we discuss how we can find the square root by using long division method. How we can find square root by long division method. Let's understand with some examples. If I want to find the square root of, let's say, 1369. If I want to find the square root of 1369, how we can find by using long division method? First we write the number, that is 1369. Now after writing the numbers, we make the pairs of two digits from the right sides, rightmost side, that is 69, then 31. We have to make the pairs from the right side, from the rightmost side, that is 6 and 9 are pair, 1 and 3 are in pairs, and then each pair represent a period. Now the first period is 13 and the next period is 69. Now the first step is that our number is 13, so we think of a number whose square is equal to or less than 13. So the nearby perfect square which is less than 13 is 3. So we write here 3 as a divisor, 3 as a quotient, 3 square is 9. Now after that we subtract 13. After that we subtract 9 from 13, we get 4, and we write down the next period, that is 69. 4, 6, 9. Now we copy the quotient, that is 3, and add to the divisor, that is 3. 3 plus 3, adding these two, we get 6, and leave a blank here after 6. Now in this blank we put a number. In this blank we put a number in such a way that the product should be equals to 469. Let's say if I put in this blank, let's say if I put 7, and again I have to multiply it by 7, because I am putting 7 here, so I have to multiply this whole number with 7. So 7 into 7, that is 49. 4 carry forward, 7 6 42, 42 plus 4 46. So 67 into 7 we get 469. So we have to put 7 here and 7 as a quotient. Now 67 into 7 we get 469. So again we subtract, the remainder is 0. So the square root of 1369 is 37. Let's take one more example. Let's say if I want to find the square root of 15,625. Now first of all I write the number, that is 15,625, and from the rightmost side I will make the pairs of 2, 25, 56 and then 1. So there are the three periods. 1 is the first period, 56 is the second period, and 25 is the third period. Now again the same process. First of all I think of a number whose square is just equal to or less than 1. So it is but obvious, 1 is square, so 1 is a divisor, 1 is a quotient, and 1 here. 1 into 1 we get 1 here, so we subtract 1 minus 1, we get 0, nothing. We write down the next period, that is 56. Now we copy the quotient here, that is 1, and adding to the divisor, that is 1. 1 plus 1 we get 2, and we put a blank here. Now in this blank I have to write down a number. Let's say if I put here 2, So I have to multiply it by 2 only, because I am writing 2, so I have to multiply it by 2 only with the same number, that is, so 2 into 2 44, I get 44, which is less than 56. Let's say if I put, instead of 2, if I put here 3 and multiply it by 3, I get 969, which is greater than 56, but I have to put a number which is just less than 56 or equal to 56. So I have to put 2 here so that I get the result 44. So I have to put 2 here and 2 here, so the result is 44. Again I subtract 56 minus 44, I get 12, and I write down the next period, that is 25. In the same process, I just copy the quotient, that is 2, and add this to the divisor, that is 22. 22 plus 2, I get 24. Again I put a blank here. I have to put a blank here. Now again, in the same way, I have to put a number in the blank in such a way that I got a number which is just equal to this one or less than or 1225. Let's say if I put 5 here, because its unit digit is 5, so I have to put 5 here, multiply with 5, I get 5 5 is 25, 2 here, 5 4 is 20, 2 12, 1 5 2 is 10, sorry, 2 carry forward, 5 2 is 10, plus 2 22, 10 plus 2, that is 12, 5 5 is 25, 5 here, that is 2, 5 4 is 20, 20 plus 2 22, 2 here, 2 carry forward, 5 2 is 10, 10 plus 2 12, that is 1225. So I have to put 5 here and here also 5, so I get 1225. There is no remainder. So the square root of 15,625 is 125. Let's take one more examples. Let's say if I have to find the square root of 58,081. 58,081. Now, first of all, what I have to do? Simply I have to write down the number, that is 58081. Now I have to make the pairs of 2 from the rightmost side, that is 81, 80 and 5. Now I have to think of a number whose square is just less than 5, that is 2. 2 square is 4. 2, 2 and 4 here. I have to subtract 5 minus 4, I get 1 here, and I have to write down the next period, that is 80. Now in this I have to just copy the quotient, that is 2, and adding to the divisor I get 4, and I have to put a blank after 4. Now I have to put in this blank such a number such that the product is equals to 180 or just less than 180. Let's say I have to put 4 here. If I put 4 here, I have to multiply it by 4 only. 4 4 is 16, 1 here, 4 4 is 16 and 1, that is 176. So which is just near to 180. Now I have to put 4 here and I have to put 4 here. 24 into 4, I get 176. Now I have to subtract 180 minus 176, I get 4. I have to write down the next period, that is 81. In this divisor I have to write down, just copy the quotient, that is 4, and add them. 44 plus 4, I get 48 with a blank. Now I have to put a digit in such a way that I get 481. So I have to put 1 here. So I have to multiply 481 with 1. When 481 is multiplied with 1, I get 481. The number as it is. There is no remainder. So the square root of 58,081 is 240. Now let we find the square root of some decimal numbers. How we can find the square roots by decimal number by using long division methods. Let's say if I have to find the square root of let's say 590.49. I have to find the square root of this, that is 590.49. So again I have to write down the number, that is 590.49. Now again I have to make the pairs of two numbers from the decimal points, because I have to count the numbers. I have to make the pairs of 2 from the decimal points. Here there is a decimal point. From this point I have to make the pairs of 2. The first pair is 90, then 5 to the left side. When I proceed from a decimal point to the left side, I have to make the pairs of 2. The first pair is 90, then 5. Again from the decimal point I have moved to the right side and I have to make the pairs of 2. From the decimal point I move to the right side and make the pairs of 2. The first pair is 49. So in this way I have to make the pairs of 2. From the decimal point, first I move to the left side with make a pair of 2. The first pair is 90, then 5. And then I move from the decimal point to the right side. The first pair is 49. Now there are the three pairs. Now again the same process. I have to think of a number whose square is less than 5, just less than 5, that is 2. 2 square is 4. 5 minus 4, I get 1 here. I have to write down the next period, that is 90. I have to just copy the question, that is 2, add them, that is 4, with a blank. Now I have to think of a number here so that the product become just less than 190. Let's say if I put 4 here, I get 176. Because I have to copy 4, I have to write down here 4, so I have to multiply the whole number with 4, that is 176. Let's say if I put 5 here instead of 4, I have to multiply this number with 5. 45 into 5, I get 5 to 225, which is greater than 190. As I want to put a number which is just less than 190, that is a 176, so I have to put 4 here. 4 here, 4 is a quotient. 190 minus 176, I get 14 remaining. I have to write down, again I copy the quotient, that is 4, adding, it becomes 48 with a blank. Now after this period there is a decimal, so we have to put decimal in the quotient. Now after decimal there is a period 49. I have to copy the 49 as a period, so I have 1449. So I have to place a number in such a way that I get this number. Let's say because its unit digit is 3, so this unit base may be 3 or maybe 7. Let's say I have to put 3 here, so I have to multiply it by 3. It becomes 9, 8 3 are 24, 4, 2, 4 3 are 12 and 14, 1449. So when I am placing 3 here, I get the answer 1449. 1449. Then there is 0. So the square root of 590.49 is 24.3. That is the answer. Let's take one more example. Let's say find the square root of 0.119716. I have to find the square root of this number. So first of all I have to write down the number, that is 0.119716. Now from the decimal point I have to make the pairs of 2. When I move to the left side there is no number, so there is no pair. Now from this decimal point I move to the right side and make the pairs of 2. The first pair is 11, then 97, then 16. So these are the pairs. Now there is a starting with the decimal point, so we place in the quotient there is a decimal point. Now after the decimal point there is a quotient 11. Now We think of a number whose square is less than 11, that is 3. I will write then 3 here. 3. 3 square is 9. 11 minus 9 I get 2 here, and write down the next period, that is 97. In this 3 I have to add 3. 3 plus 3 I get 6 with a blank. Now I have to place a number in this blank so that the product is become just equal to or less than 297. Let's say I have to put 4 here. 4 4 is 16, 1, 6, 6, 6 4 is 24 or 1, 256. I get 256, which is just near to 297. Let's say if I put, instead of 4, I have to put 5 here, so I have to multiply with 5. When I multiply with 5, I get 5 4 is 25, 2, 325, which is greater than 297. So I have to put 4 here. So it becomes 256. 7 minus 6, I get 1 here, 41. I have to write down the next figure, that is 116. Again I same copy the question, that is 4. I get 68 with a blank. Now I have to write down a number so that the product become 41116. So since its unit digit is 6, so this number should be either 4 or 6. Let's say I put 6 here. I put 6 here. So I have to multiply the number with 6. 6 6 is 36. I get 3 here. 6 8 is 48. 48 plus 3, that is 51. 1 5. 6 6 is 36 plus 5, that is 41. I get 4116. So this should be 6. And this should be 6. So I get 4116. So the square root of 0.119716 is 0.346. So in this way we can find the square root by using long division methods. Now let's do some problem related to long division methods. The question is, what least number must be subtracted from 16,160 so that the result becomes a perfect square. So what least number must be subtracted from 16,160 so that the result become a perfect square? So again we have to solve it by long division method. First of all, I have to find the square root of 16,160. Now I have to find the square root of this 16,160. I have to make the pairs of 2 from the rightmost side, that is 60, 61 and 1. Now I have to think of a number whose square is just equals to 1. Let's say 1, 1, 1. Subtracted, 1, 1 get cancelled. I have to write down the next period, that is 61. 1, I have to copy the question, that is 1. I have to add them. 1 plus 1, that is 2 with a blank. I have to put a number such that the product becomes less than 61. Let's say I have to put 2 here. So it becomes 2. 22 into 2, I get 44. Now 61 minus 44, I get 17. I have to write down the next period, that is 60. I have to just copy the question, that is 2, that is 24 with a blank. Now I have to put a number so that the product is just less than 1760 or equal to 1760. Let's say I have to put 7 here. When I put 7 here, I have to multiply the number with 7. 7 7 is 49. I get 4 here. 7 4 is 28. 28 plus 4 32. 2 3 7 2 is 14. So I have to put 7 here. So I have to put 7 here. I get 1729. Now 1760 minus 1729, I get 31. So this number 31, so that 16,160 become a perfect square. I have to subtract 31 from 16,160 so that the result becomes a perfect square, so that the result, that is the answer is 31. We have to subtract 30. My next question is, what must be added to 5607 to make the sum a perfect square, to make the sum a perfect square. That's it. As we know that when there is a unit digit as 2378, the number is never be a perfect square. So definitely 5607 is not a perfect square. Now we have to subtract some number so that the difference that we get is a perfect square. So we have to add something so that it become a perfect square. Let's see. First of all, we find the square root of 5607 by using long division method. Again, I have to make the pairs of 2 from the right side, 56 and 07. Now the number whose square is just less than 56 is 7. The number is, I have to write in the next period, that is 07. I have to write down 7 here, add them 14 with a blank. Now I have to write down a number whose product, such that the product of the number becomes just less than 707. So I have to put 4 here. When I put 4 here, I have to multiply the number 144 with 4 only. I get 576. So I have to put 4 here, 576. So 131 is the remainder. Now if the question is of subtraction, then our answer should be 131. I have to subtract 5607. I have to subtract 131 from 5607 so that the difference become a perfect square. But our question is of addition. For addition, since the 74 square is less than 5607, so the next number, that is 75, the 75, as 74 square is less than 5607, that is 74 square is less than 5607. So after 74 there should be 75. So 75 square is definitely is greater than 5607, and the square of 75, the square of 75 is 5625. So our question is, what should be added to 5607 so that it become a perfect square? So we have to find the difference of these two, that is 5625 and 5607. So we must 5625 minus, that is difference of these two numbers, that is 5625 and 5607. The answer is, so we have to must add 18 in this 5607 so that 5607 plus 18 gives you 5625, which is the square of 75. So in this way we can do the problems with the help of long division method. Now one more problem. Let's see. Find the value of under root of 2 up to 3 decimal places. Let's say if I want to find the value of root 2 up to 3 decimal places, this can be done by using long division method. As we know that root 2 is not a perfect square, so I have to find the value of root 2 up to 3 decimal places. I have to write down 2 here. I have put a decimal sign. since I have to find the value up to 3 decimal places, so I have to put 6 zeros, that is double of the decimal places. There are 3 decimal places, so I have to put 6 zeros after decimal sign. Now I have to make the pairs of 2 from the decimal point to the left side, there is one pair only, and from this decimal point I have to make the pairs of 2 moving to the right side, that is 3 places. Now let's start the process. Now we think of a number whose square is just less than 2, let's say 1. I have to subtract 2 minus 1, I get 1 here. I have to just copy the question. 1 plus 1, I get 2 here with a blank. Now after this period there is a decimal sign, so I have to put decimal here. Now I have to copy the next period, that is 100. Now I have to put a number such that the product becomes less than or equal to 100. Let's say 4 here. When I put 4 here, I have to multiply 24 with 4. It becomes 96. Now subtracting 100 minus 96, I get 4 here. I put the next period, that is 100 again. I have to just add the question, that is 4. 24 plus 4, I get 28. Again I have to put a number such that the product becomes equal to or less than 400. If I put 1 here, I get 281. But when I put 2 here, I get 282, and 282 should be multiplied with 2, which is greater than 400. So I have to put 1 here only. 1 here. 281 into 1, I get 281 here. 400 minus 281, I get 9. I get 119 here. Again I copy the next period, that is 2 zeros. Again I copy the question, that is 1. 281 plus 1, that is 282 with a blank. Now I have to place a number here such that the product becomes equal to or less than 11,900. Let's say I put 4 here. 282. I have to do 4 here. So I have to multiply with 4 only. 4 4 is 16, 1. 4 2 8 or 1 9. 4 2 8 32, 2 3. 4 2 8 or 3 11. That is 11,296. So I have to put 4 here. And the same way I put 4 here. So the product becomes 11,296. I have to difference 300. The decimal value of root 2 up to 3 decimal places is 1.414. The value of root 2 up to 3 decimal places is 1.414. So in this way we can find the nearby decimal values. Thank you.